So in this video we're going to talk about the binary search tree and its properties. So the binary search tree, also in short we can call this BST. Now the BST is a binary tree. That means, so as we know, in case of binary tree we can have at most 2 children. That means we can have 0 child, we can have 1 child, and also we can have 2 child. So suppose we have a node. Now if the node have no child, then also we can call this a binary tree. If the node has only 1 child, this can be the left child or this can be the right child. And also if we have left child and the right child, then also we can call this a binary tree. So a binary tree is where we have at most 2 children. So our binary search tree is also a binary tree. That means here also we're gonna have at most 2 children. Now the question is, when we're gonna call a binary tree as a binary search tree. So the binary tree has to follow a certain set of rules, then only we can call this a binary search tree. So rule number 1, so first of all, the left child of the binary tree should be lesser than the node. So suppose we have a node with the value 10. Now the left child of this node should have lesser value like 8. And second rule is that the right child, so the right child value should be greater than the node. So that means here the right child of this node should have greater value like 15. And the rule number 3 is that here both the left and the right subtree also has to be BST. So that means in our tree, suppose we have the left subtree with bunch of nodes and also we have right subtree with bunch of nodes. Now both of these subtrees must follow these 2 rules. That means, so here the left child should have value lesser than the node. So here we can have the value 7, and the right child should have value greater than the node. So here we can have the value 9, which is greater than the node 8. So this is for the left subtree. So the same rule also applicable for the right subtree also. So that means here also the left child should have value lesser than the node and the right child should have value greater than the node. When our binary tree follows these rules, then only we can call this a binary search tree. And also in a binary search tree, we do not have any duplicate values. So all the nodes will have distinct values. So if the value is smaller than the node, they will be placed in the left. If the value is greater than the node, then the node will be placed on the right side. And also in case of this binary search tree, we have some special property. So here if we perform the in order traversal, then all the values of this tree will be sorted in ascending order. So here we have the binary search tree. Now if we perform the in order traversal, then all the elements will be sorted in ascending order. So let's just perform the in order traversal of this tree. So we're gonna start the traversal from this root node and we're gonna continue to traverse. So whenever we reach bottom of one node, then we're gonna include this in our in order traversal. So first of all we have the 7, then we reach bottom of the 8, then we reach bottom of 9. So we're gonna continue to traverse. Now we're reaching bottom of the node 10, and then we are reaching bottom of the node 14, then we are reaching bottom of the node 15, and then lastly we are reaching bottom of the node 16. So this is the shortcut trick to find the traversal of any tree. So in the earlier video I have talked about how we can easily find the traversal of any tree. So that means here we have the in order traversal of this tree, and you can see all the values are sorted in ascending order. So that means we can say that this is one binary search tree. So there can be question to check whether a binary tree is a binary search tree or not. So in that case we can perform this in order traversal. So if the values are sorted in ascending order, then we can say that this is one binary search tree. So let's just talk about the time complexity of the binary search tree. So in a BST we can perform the search operation. That means we can look for one specific value in a binary search tree. And also we can perform the insertion of one node, and also we can perform the deletion of one node from the binary search tree. Now in average case it has the complexity of order of log n, and in worst case it has the complexity of order of n. So the worst case happens when the tree is skewed. That means each node has only one child, either the left or the right child. In that case it behaves more like the linked list. So in that case we're gonna have the worst performance. And also in case of the binary search tree, the leftmost node will have the smallest value and the rightmost node will have the largest value. So hope you understand about the binary search tree and the properties of the binary search tree. See you in the next one. Take care.